What is the loneliest place you can imagine? Take a moment to consider this question. Let it settle in your mind. Perhaps you picture a single house standing alone on an endless prairie, the wind blowing through tall grass that stretches to the horizon in every direction. No neighbors, no roads, just earth and sky and silence. Or perhaps you imagine an island in the middle of the ocean, a small patch of sand and palm trees surrounded by thousands of miles of water. The nearest human being is days away by boat. The only sounds are waves and wind and the occasional cry of seabirds. Maybe you think of a cabin in the mountains, hidden in a valley where snow falls for months at a time, miles from the nearest road, miles from the nearest town, a place where you could disappear and no one would find you. These are lonely places, certainly. Places where a human being might feel isolated, cut off, alone. But tonight, I want you to imagine something far more profound. Imagine a place where the nearest neighbor is not miles away, but millions of light years. Where the darkness stretches so far, so impossibly far, that light itself grows tired trying to cross it. Where emptiness has emptiness as its only companion. Where the void gazes into itself and finds nothing gazing back. Tonight, we journey to the loneliest places in the universe. We will visit cosmic voids so vast that our entire galaxy, with its 400 billion stars, could fit inside them billions of times over. We will find planets that wander forever through the darkness between stars, frozen worlds that have never known the warmth of a sun and never will. We will meet a galaxy so isolated that its inhabitants, if they exist, might look up at their night sky and see almost nothing. They might believe for thousands of years that they are utterly alone in all of existence, that their island of stars is the only island there is. And we will follow a small spacecraft built by human hands, carrying human hopes, as it drifts further and further from home. A tiny messenger carrying a golden record full of sounds and images from Earth. A message that may never be found, but was sent anyway. These are not stories of sadness, not really. They are stories of scale, stories of perspective, stories that remind us how vast the cosmos truly is and how small we are within it. But there is also comfort here. A strange and unexpected comfort that comes from knowing that loneliness exists at every level of the universe. That even in the emptiest places, in the darkest voids, in the most isolated corners of existence, something endures, something persists, something is. So settle in, let your body relax, let your thoughts drift like clouds across a quiet sky, and let us explore together the quiet places of the universe. The places where silence reigns, the places where darkness stretches forever, the places that remind us what it truly means to be alone. In 1981, astronomer Robert Kirshner was conducting a survey of distant galaxies. He and his team were working at the Kitt Peak National Observatory in Arizona, using a technique called redshift measurement to map the positions of galaxies across the universe. It was painstaking work. Each galaxy had to be observed individually. Its light had to be analyzed. Its distance had to be calculated. The goal was simple but ambitious. They wanted to understand how galaxies cluster together across the cosmos, how matter is distributed throughout the universe. They expected to find the usual cosmic landscape, groups and clusters of galaxies, threaded together like a vast web, connected by gravity across billions of light years. But in one particular direction, in the direction of the constellation Boötes, they found something unexpected. Nothing. At first, they thought it must be an error, a gap in their data, an oversight in their observations. Surely there must be galaxies there. Galaxies are everywhere. The universe is filled with them. But as they gathered more data, as they pointed their telescopes again and again at that same patch of sky, the result remained the same. Nothing, or very nearly nothing. The Boötes void, sometimes called the Great Nothing, spans approximately 330 million light-years across. Let me help you understand what that number means. Light is the fastest thing in the universe. Nothing travels faster. A beam of light moves at 186,000 miles every single second. At that speed, light can travel from the Earth to the Moon in just over 1 second. It can travel from the Earth to the Sun in about 8 minutes. But to cross the Boötes void, that same beam of light would need 330 million years. 330 million years of traveling at the fastest possible speed just to get from one side to the other. Our entire Milky Way galaxy, our cosmic home, is about 100,000 light-years wide. It contains somewhere between 200 and 400 billion stars. It is unimaginably vast by human standards. And yet, you could fit the Milky Way inside the Boötes void billions of times over. Billions of copies of our entire galaxy, and still have room to spare. But here is the truly strange part, the part that puzzled astronomers then and continues to puzzle them now. Inside this vast emptiness, astronomers have found only about 60 galaxies. 60! In a region of space where we would expect to find roughly 2,000. That means the Boötes void contains 97% fewer galaxies than it should. 97% emptier than the rest of the universe. It is not just empty. It is impossibly, inexplicably empty. Astronomer Greg Aldering, who has spent years studying cosmic voids, once offered a haunting perspective on what it would mean to live inside this emptiness. He said, "If the Milky Way had been in the center of the Boötes void, we wouldn't have known there were other galaxies until the 1960s. Think about that for a moment. Let it sink in. Humanity first discovered that other galaxies exist in the 1920s. Edwin Hubble proved that the Andromeda Nebula was actually a separate galaxy, a whole other island universe far beyond our own. It was one of the most important discoveries in the history of science. But if we had evolved inside the Boötes void, we would have spent an additional 40 years believing we were alone. We would have thought that our galaxy was the entire universe, that beyond the edge of the Milky Way, there was only infinite darkness, only void, only nothing. For 40 more years, we would have believed that we were the only island of light in an ocean of eternal night. The Boötes void sits roughly 700 million light-years from Earth. We can observe it from a safe distance. We can map its edges. We can count the few lonely galaxies that drift within it. But we cannot truly comprehend what it would feel like to exist inside such emptiness. To look up at your night sky and see almost nothing. A handful of faint smudges where there should be thousands. A sky that is more darkness than light. Some scientists believe the Boötes void formed through the merger of smaller voids over billions of years. Empty regions combining and growing, like soap bubbles joining together into one massive bubble. Others wonder if something else, some unknown process, some cosmic phenomenon we don't yet understand, carved out this pocket of emptiness in the fabric of the universe. We still don't know for certain. Whatever its origin, the Boötes void remains one of the largest known structures in the universe. But it is not a structure made of matter, not a structure made of stars or gas or dust. It is a structure made of absence, a shape defined by what is not there rather than what is. A cathedral of nothing. The Boötes void is strange and vast and far away, 700 million light-years from Earth, so distant that its light began traveling toward us before complex life even existed on our planet. It is easy to think of it as something separate from us, something out there, a curiosity in the distant cosmos that has nothing to do with our daily lives. But here is something even more unsettling. We may not need to imagine what it feels like to live in a cosmic void, because we already do. In 2013, a team of astronomers led by Ryan Keenan, Amy Barger, and Lennox Cowie made a remarkable discovery. They had been studying the distribution of galaxies around us, mapping the cosmic neighborhood, trying to understand the structure of the universe in our local region. What they found was unexpected, disturbing even. They identified a cosmic void approximately 2 billion light-years across. 2 billion, not million, billion. And our Milky Way galaxy, our home, floats near its center. They call it the KBC void, named after the 3 astronomers who discovered it. It is the largest void ever observed. 2 billion light-years. That is more than 6 times larger than the Boötes void, a sphere of relative emptiness so vast that the human mind struggles to conceive of it, and we are inside it. Inside the KBC void, matter is sparse. The density of galaxies is roughly 20 to 50% lower than the cosmic average. Where there should be galaxies, there are fewer. Where there should be matter, there is less. It is not as empty as the Boötes void, not as extreme, but it is undeniably, measurably emptier than the universe around it, and we live at its heart. Consider what this means. Every galaxy you have ever seen in a photograph is inside this void. Every star that has ever been given a name is inside this void. Every planet discovered by our telescopes, every nebula captured by Hubble and Webb, all of it exists within this vast underdensity. The Andromeda Galaxy, the Triangulum Galaxy, the Virgo Cluster, the Local Group, all of it, surrounded by emptiness. We are inside a cosmic bubble, and we never knew. Beyond the edges of the KBC void lie the denser regions of the universe, galaxy clusters packed more tightly together, superclusters spanning hundreds of millions of light-years. The cosmic web in its full glory, threads of matter connecting nodes of light. But from where we sit, those regions are impossibly far away. The walls of our void, the edges of our bubble, are hundreds of millions of light-years distant. Some scientists believe the KBC void may explain a mystery that has puzzled cosmologists for years. When we measure how fast the universe is expanding using nearby objects, like certain types of supernovae in our cosmic neighborhood, we get one number. When we measure using distant objects, like the cosmic microwave background radiation from the early universe, we get a different number. This disagreement is called the Hubble tension. It has caused endless debate among astronomers. Papers have been written, conferences have been held, and still, no one can fully explain why the two measurements don't match. But if we live inside a void, the answer might be simpler than we thought. The denser regions surrounding our void would exert a gravitational pull. They would tug at everything inside the void, pulling it outward toward the walls. This could make space appear to expand faster in our local region, even if the overall expansion rate of the universe is different. We might be measuring the universe incorrectly, simply because of where we happen to be sitting. It is a humbling thought. We believed we were observing the universe from a typical vantage point, a normal location, an average seat in the cosmic theater. We assumed our view was representative, that what we see is what the universe looks like everywhere, but we are not average at all. We are in a void, a local hole in the fabric of existence, a bubble of emptiness 2 billion light-years across. And everything we know about the cosmos, every measurement we have made, every conclusion we have drawn, has been filtered through that peculiar position. Perhaps loneliness is not something we need to travel far to find. Perhaps it has been with us all along, surrounding us, enveloping us, holding us in its quiet, invisible embrace. We are creatures of a void, and we never even noticed. Now, let us leave the voids behind and visit something smaller, something more personal, something that might stir different feelings in your heart. We are going to visit a world, a planet, but not a planet like Earth, not a planet warmed by a nearby star, not a planet with seasons and sunrises and the familiar rhythm of day and night. This is a rogue planet. A rogue planet is a world without a sun. It has no star to orbit, no source of warmth and light to sustain it. It does not belong to any solar system. It answers to no gravitational master. It simply drifts through the vast emptiness between the stars, through the cold and the dark, forever. Billions of years ago, this planet may have formed in a solar system much like ours. It may have coalesced from a disk of gas and dust surrounding a young star. It may have had siblings, other planets forming nearby, moons gathering around it. Perhaps it had oceans. Perhaps it had an atmosphere. Perhaps for a time, it even had conditions that could have supported life. But something happened. Maybe a gravitational encounter with a larger planet threw it off course. Maybe a close pass with another star disrupted its orbit. Maybe the chaotic dynamics of a young solar system simply flung it outward, like a stone released from a sling. Whatever the cause, this world was ejected, cast out, sent tumbling into the void between stars, with no way to return. It has been wandering ever since. Billions of years of drifting, billions of years of darkness, billions of years of cold that deepens with every passing moment. Scientists now believe that rogue planets are far more common than we ever imagined. They may outnumber stars in our galaxy by as much as 20 to 1. NASA researcher David Bennett estimates that the Milky Way alone may contain trillions of these wandering worlds. Trillions of frozen planets drifting through the darkness. Trillions of worlds that have never known warmth. Trillions of cosmic orphans with no home and no hope of finding one. Without starlight, the surface of a rogue planet plunges toward temperatures we can barely comprehend. -270 degrees Celsius, just a few degrees above absolute zero, the coldest temperature possible in our universe. At these temperatures, any atmosphere would freeze solid. Nitrogen would fall as snow. Oxygen would become ice. The very air would crystallize and settle on the ground in drifts miles deep. Any ocean would become a shell of ice. Not just frozen at the surface, but frozen all the way down, solid as rock. But here is something remarkable. Something that offers a glimmer of hope in all this frozen darkness. Beneath that ice, some rogue planets may still harbor liquid water. The heat would not come from a star. There is no star. The heat would come from within. Deep inside rocky planets like Earth, radioactive elements slowly decay. Uranium, thorium, potassium. These elements release energy as they break down. Energy that warms the planet's interior over billions of years. On Earth, this heat drives volcanic activity and plate tectonics. But on a rogue planet with a thick enough shell of ice acting as insulation, this internal heat might be enough to maintain liquid water. Not on the surface. The surface would be frozen beyond imagination. But deep below, in lightless oceans beneath miles of ice, water might flow, might circulate, might provide a home for something unexpected. Scientists have a name for such worlds. They call them Steppenwolf planet. Lone wolves wandering the galactic steppe, carrying hidden oceans within them, carrying the possibility of life in places where no life should be possible. Imagine what life on a Steppenwolf planet might be like. Creatures living in eternal darkness. No sun to mark the passage of time. No seasons to structure the years. No concept of day or night, because there is no day. There is only night, always and forever. Such creatures might cluster around hydrothermal vents on the ocean floor, where heat and chemicals seep up from the planet's interior. They might evolve without eyes, because in absolute darkness, eyes serve no purpose. They might live for billions of years, generation after generation, never knowing that above the ice, above the frozen atmosphere, above the eternal darkness, an entire universe blazes with light. They would have no word for sun, no concept of stars, no mythology of the sky, because they would never see the sky. In 2020, astronomers detected a rogue planet roughly the size of Mars. They found it using a technique called gravitational microlensing. When a massive object passes between Earth and a distant star, it bends the light from that star. The star appears to brighten briefly, then dim again as the object passes. This particular event lasted only 41.5 minutes. A brief flicker of light, a momentary distortion, and then the rogue planet was gone. Back into the darkness, untraceable, unknown. We caught a glimpse of a wandering world, and then lost it forever. In 2023, the James Webb Space Telescope discovered something even stranger. While observing the Orion Nebula, a vast cloud of gas and dust where new stars are being born, astronomers found pairs of rogue planets, Jupiter-sized worlds, orbiting each other. Two giants, ejected from their solar system together, now keeping each other company through 20,000-year orbits, circling each other in the darkness, bound by gravity, together in their exile. Astronomers call them jumbos, Jupiter mass binary objects. Even in exile, even cast out from their homes into the endless void, they found companionship. There is something strangely beautiful about that, something almost hopeful. Even rogue planets do not always wander alone. The next generation of space telescopes will find many more of these wandering worlds. NASA's Nancy Grace Roman Space Telescope, scheduled to launch in 2027, is expected to discover approximately 400 Earth-sized rogue planets. 400 frozen worlds, each with its own history, each wandering on its own path through the galaxy. And for every one we find, millions more will remain hidden, invisible, undetected, drifting through the darkness where no telescope can see them, cold, silent, alone. Let us now travel further, much further, beyond the voids, beyond the wandering planets, out into the deep universe where distances become almost meaningless. 293 million light-years from Earth, there is a galaxy. It is a beautiful galaxy, a barred spiral, much like our own Milky Way, with graceful arms curving outward from a bright central core. Billions of stars populate those arms. Perhaps trillions of planets orbit those stars. Nebulae glow within it. New stars are being born. Old stars are dying. From the outside, it looks like countless other galaxies scattered across the cosmos. Ordinary, unremarkable, just another island of light in the vast cosmic ocean. Its name is MCG plus 01-02-015, and it is the loneliest galaxy we have ever found. In every direction from this galaxy, for 100 million light-years, there is nothing. No other major galaxy, no cluster, no group, no cosmic neighbor of any kind. 100 million light-years of emptiness in every direction. Up, down, left, right, forward, backward. Nothing but void. To understand just how unusual this is, consider our own cosmic neighborhood. The Milky Way is not alone. We have neighbors, lots of them. The Andromeda Galaxy is about 2.5 million light-years away. The Triangulum Galaxy is roughly 3 million light-years distant. Dozens of smaller dwarf galaxies orbit around us and around Andromeda, satellites bound by gravity to their larger hosts. Together, we form what astronomers call the local group, a collection of more than 80 galaxies bound together by mutual gravitational attraction. And beyond the local group, within 100 million light-years of the Milky Way, there are hundreds of thousands of other galaxies. The Virgo cluster alone contains over 1,000. The Fornax cluster contains hundreds more. Our region of space is crowded, rich with galaxies, teeming with cosmic neighbors. MCG plus 01-02-015 has none of this. No local group, no neighbors, no clusters nearby, no companions at all. It drifts alone in an ocean of void, like a single ship on an endless sea with no other vessels in sight, no land on any horizon, no lighthouse, no harbor, just water and sky and solitude forever. The European Space Agency once described what it would be like to live inside this lonely galaxy. They wrote, "If our galaxy, the Milky Way, were situated in the same way, we would not have known of the existence of other galaxies until the 1960s. Imagine being part of a civilization in that galaxy. Imagine your species developing astronomy, learning to build telescopes, learning to analyze light, mapping your stars with ever-increasing precision, cataloging your planets, studying your stellar neighborhoods. For thousands of years, your astronomers would gaze outward, beyond the edge of your galaxy, searching for something else, anything else, some sign that you are not alone, and they would find nothing. No spiral shapes in the distance, no fuzzy patches that might be other island universes, just darkness. Perfect, unbroken darkness. stretching to infinity in every direction. Your philosophers would debate what this means. Your religions would incorporate it into their cosmologies. Your scientists would develop theories about why your galaxy exists in such isolation. But the simplest explanation, the most obvious conclusion, would be that you are alone, that your galaxy is the entire universe, that there is nothing else, that beyond the stars you can see, there is only void, only darkness, only the end of everything. Then one day, perhaps in your equivalent of the 1960s, your telescopes finally become powerful enough. Your technology advances just far enough to detect a faint smudge of light, barely visible, almost lost in the noise of your instruments. But there, undeniably there, another galaxy, 100 million light-years away, so far that the light you're seeing began its journey when your world was unimaginably different. Before your species even existed. You are not alone, after all. But your nearest neighbor is so impossibly far, so unreachably distant, that the discovery might feel almost meaningless. You cannot visit them. You cannot communicate with them. You can only know that they exist, somewhere in the unimaginable distance. Would that knowledge bring comfort? Or would it deepen the loneliness? To know that others exist, but that they are forever out of reach. To see a distant light, but never feel its warmth. There is one small mercy for this lonely galaxy, because MCG plus 01-02-015 has likely never experienced a galactic merger, never collided with another galaxy, never been gravitationally disturbed by a passing neighbor. It remains remarkably pristine. Its spiral structure is clean and undistorted. Its stellar populations have evolved in isolation. Its history has unfolded without external interference. For astronomers, this makes it valuable, a natural laboratory, a place to study how galaxies evolve when left completely alone. What happens when there are no collisions, no mergers, no interactions of any kind? In its loneliness, it has become scientifically precious. But I wonder sometimes about the beings who might live there, if they exist. If some planet in that lonely galaxy has produced life, intelligence, consciousness, do they look up at their empty sky and feel the weight of all that darkness pressing down? Do they feel the isolation, the cosmic loneliness? Or have they found peace in it? Perhaps they tell themselves, we have everything we need. Our stars, our worlds, our own vast home. We lack for nothing. We are complete unto ourselves. Perhaps loneliness, at that scale, transforms into something else entirely. Something like independence, something like self-sufficiency, something like freedom. We have spoken of cosmic voids, those vast empty spaces between the filaments of the cosmic web. We have visited wandering planets, frozen worlds drifting through interstellar darkness. We have met the loneliest galaxy, an island of light in an ocean of void. But what of stars? Surely stars, by their very nature, belong to galaxies. They form in nebulae within galaxies. They orbit galactic centers. They live out their lives within the arms and bulges and halos of their cosmic homes. They die within galaxies, becoming white dwarfs or neutron stars or black holes, but always remaining part of the galactic family. And yet, some stars escape. They are called hypervelocity stars, and they are among the fastest objects in the universe. The current record holder is a star known simply as J0927. It is a small, unassuming star, not particularly bright or massive, but it is moving at almost unbelievable speed, approximately 2,285 kilometers per second. To put that in perspective, that is over 5 million miles per hour. Fast enough to circle the Earth at the equator in just 28 seconds. Fast enough to travel from New York to Los Angeles in 2 seconds. Fast enough to cross from New York to Mississippi in less than 1 second. At this speed, the star has enough velocity to escape the gravitational pull of its entire galaxy. The Milky Way cannot hold it. Nothing can hold it. It will drift outward forever into the void between galaxies. It will never return. How does a star achieve such incredible speed? Through an encounter with something even more massive, something with gravitational power beyond comprehension. A supermassive black hole. Picture a binary star system. Two stars orbiting each other, bound together by gravity. They have circled each other for millions of years, perhaps billions, but their orbit carries them too close to the black hole at the center of their galaxy. The gravitational forces become extreme. The tidal effects become catastrophic. One star is captured, pulled into a tight orbit around the black hole. It may eventually spiral inward and be consumed entirely. But the other star, the companion, is flung outward, like a stone released from a sling, like a ball thrown by a cosmic pitcher with infinite strength. This is called the Hills mechanism, named after the astronomer Jack Hills, who first proposed it in 1988. Our own galaxy's central black hole, Sagittarius A star, with a mass of 4 million suns, ejects roughly one star every 100,000 years through this process. And so, over billions of years, the space between galaxies has become populated with these exiles. Stars that once belonged to cosmic families. Stars that once had neighbors. Stars that once saw the glow of a galactic disk across their skies. Now, they wander alone. Through the intergalactic void, through darkness that makes interstellar space seem crowded by comparison. In the Virgo cluster, a massive collection of over 2,000 galaxies, about 54 million light-years from Earth, astronomers estimate that approximately 1 trillion stars exist outside any galaxy. 1 trillion intergalactic stars. They make up roughly 10% of the cluster's total stellar mass. 1 star in 10, belonging to no one, orbiting nothing but the cluster itself. Some scientists believe that the number of intergalactic stars is even higher than we realize. As much as half of all stars in the universe may exist between galaxies. Half. Cast out through mergers, flung away during collisions, ejected through gravitational chaos over billions of years of cosmic evolution. Half of all the stars that have ever existed may be wandering through the void, alone, homeless, forever. Now imagine a planet orbiting one of these intergalactic stars, a world that exists in the space between galaxies. What would its night sky look like? There would be no constellations, no Milky Way stretching overhead, no band of starlight crossing the sky, no familiar patterns passed down through generations of mythology and navigation. The nearest neighboring star might be millions of light years away, so far that its light would be invisible to the naked eye. Instead of stars, the sky would show only the faint smudges of distant galaxies, spiral shapes and elliptical blobs, impossibly far away. Beautiful, perhaps, but cold, unreachable. You could build the most powerful telescope imaginable and still see only darkness in most directions. Only void. Only emptiness. This is the ultimate isolation. A sun with no siblings. A solar system with no neighborhood. A world where the concept of nearby has no meaning at all. The closest thing to you, the closest star, the closest planet, the closest anything, would be so far away that traveling there would be utterly impossible. Not just difficult, not just impractical, impossible. And yet, these intergalactic stars continue to burn. They fuse hydrogen into helium, helium into carbon, carbon into heavier elements. They follow the same physics as every other star. They shine their light into the void, even though almost nothing is there to receive it. They may have planets. They may have moons. They may have all the ingredients necessary for life. Life, perhaps, could find a way, even here, even in the loneliest corner of existence. But such life would know a profound truth. A truth that we, in our crowded corner of the Milky Way, can only imagine. The universe is vast, incomprehensibly vast, and most of it, the overwhelming majority of it, is empty. We are the exception, not the rule. But now, let us return home. Or rather, let us follow something that left home long ago and will never return. This is Voyager 1, the loneliest human-made object in existence. Launched on September 5, 1977, it has been traveling away from Earth for nearly 50 years. Today, it drifts approximately 25 billion kilometers from home, about 170 times the distance from Earth to the Sun. At its current speed of 38,000 miles per hour, Voyager crosses roughly 1 million miles every day. And yet, even at that speed, it will take 18,000 years to travel a single light year. The stars are very, very far away. On August 25, 2012, Voyager 1 crossed the heliopause, the boundary where our Sun's influence ends and interstellar space begins. It was the first human-made object to enter the space between stars. What surrounds Voyager now? Not the warm solar wind that bathes our inner planets. Instead, cold plasma from ancient supernovae, galactic cosmic rays that have been traveling through the galaxy for millions of years. And emptiness. Profound, unimaginable emptiness. NASA describes interstellar space as normally like a quiet lake. But when our sun erupts with solar flares, it sends shock waves outward that cause the plasma around Voyager to vibrate, to sing. Even here, 25 billion kilometers from home, we can still feel the echo of our star. In approximately November of 2026, Voyager 1 will cross a symbolic threshold. It will be one light day from Earth. That means when we send a command to the spacecraft, it will take a full day for the signal to arrive, and another full day for any response to return. A 2-day round trip for a conversation across the void. Voyager still has 3 functioning instruments. They study the magnetic field, the plasma, the charged particles that drift through interstellar space. And remarkably, after nearly 50 years, we can still communicate with it. The signal is faint, about 23 watts, the power of a refrigerator light bulb, but it reaches us. NASA expects to maintain contact until roughly 2036. After that, there will be no more power, no more signals, just silence. But Voyager will not stop. It will continue drifting through the galaxy, carried by its own momentum, for billions of years. Attached to Voyager is a golden record, a message in a bottle, thrown into an infinite ocean. It contains 116 images, photographs of Earth, of human beings, of our solar system. It carries 90 minutes of sounds, ocean waves, thunder, the calls of whales, a mother's heartbeat, laughter, and music. Bach, Beethoven, Chuck Berry, traditional songs from cultures around the world. There are greetings in 55 languages, from children, from adults, from speakers of ancient languages that no longer have living voices. And hidden within the record, compressed into about 1 minute of audio, are the brainwaves and heartbeat of Anne Druyan, recorded as she meditated on the history of Earth and her love for Carl Sagan. She later became his wife. President Jimmy Carter included a message with the record. It reads, "This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. In 40,000 years, Voyager will pass within 1.6 light-years of a star called Gliese 445. It will not stop there. It will continue onward into the darkness. The golden record is designed to survive for 1 billion years. 1 billion years. Long after our sun has changed and our Earth has transformed beyond recognition. Long after every person who built Voyager, who programmed it, who loved it, has returned to stardust, the record will remain. Drifting, waiting, carrying the memory of a small blue world that once looked up at the stars and decided to say hello. We have seen the Boötes void, 330 million light-years of almost nothing. We have learned that we ourselves live inside a void 2 billion light-years across. We have wandered with rogue planets through frozen eternities and visited a galaxy that may believe itself alone in all existence. What does it mean, this loneliness we have witnessed? Perhaps nothing. The universe does not feel. It does not suffer from isolation. The void does not know it is empty. The rogue planet does not mourn its lost sun. They simply are. Existence without awareness. Matter without meaning. But we are different. We are the universe aware of itself, the cosmos looking at its own reflection. And when we peer into the void, something within us responds, something ancient, something deeply human. We have evolved to fear isolation. Our ancestors survived by staying together, in families, in tribes, in communities. Loneliness for a human being is not just uncomfortable, it can be dangerous. Our brains interpret it as a threat, as something to be avoided at all costs. And yet, when we look at the loneliest places in the cosmos, we do not feel only fear. We feel wonder, awe, a strange kind of peace, because loneliness, at this scale, transforms into something else. It becomes spaciousness, stillness, a reminder that not every corner of existence needs to be filled. The voids are not wounds in the universe. They are part of its structure, part of its design. Without them, the cosmic web could not exist. The galaxies would have no room to breathe. The universe would be uniform, featureless, without the contrast that makes patterns possible. Emptiness is not the absence of something. It is the presence of potential, the space where something might someday be. And what of Voyager? Is it lonely out there, beyond the edge of everything we know? In one sense, yes. It is further from human warmth than any object we have ever created. It will never feel a touch, hear a voice, sense the presence of another being. But in another sense, Voyager carries all of us with it. Every greeting on that record, every song, every image of human hands and human hearts. It is not alone. It is a messenger, carrying the memory of connection into the void. And perhaps that is enough. Tonight, as you drift toward sleep, consider this. You exist in a universe so vast that loneliness is built into its structure. Voids that span billions of light years, planets that wander without suns, galaxies that float 100 million light years from their nearest neighbor. And yet, here you are, on a small blue world in a galaxy of 400 billion stars, surrounded by neighbors both cosmic and human. You are not alone. You have never been alone. Even the atoms in your body were forged in ancient stars, connected to the universe through chains of causation stretching back billions of years. Loneliness is real. It is a feeling that visits all of us, but it is not the whole truth. The whole truth is this: you are part of everything, connected to everything. The universe dreaming itself, for a brief moment, in human form. And when you close your eyes tonight, you carry all of it with you. The voids, the wandering planets, the isolated galaxies. Voyager, drifting through the darkness with its cargo of human hope. You are never truly alone. Let the images fade. Let the numbers slip away. The distances, the timescales, the impossible vastness of it all. You do not need to hold on to anything tonight. The universe will continue its slow dance whether you watch or not. The voids will remain empty. The rogue planets will continue their wandering. Voyager will drift onward, carrying its golden cargo toward distant stars. All of it will still be there tomorrow, and the day after, and for billions of years to come. But for now, you can rest. Breathe in. Feel your body against whatever surface holds you. Feel the weight of gravity, that same force that shapes galaxies, that bends light, that holds planets in their orbits. It holds you too, gently, faithfully. Breathe out. Let go of the day. Let go of tomorrow. Let go of everything that does not serve you in this moment. You are safe. You are warm. You are exactly where you need to be. The loneliest places in the universe are far away tonight. You are surrounded by air, by warmth, by the quiet presence of a world that has cradled life for billions of years. Rest now. In the morning, the universe will still be there, vast, beautiful, full of mysteries we have not yet imagined, but that is for tomorrow. Tonight, there is only this moment, this breath, this gentle darkness. Sleep well. You are part of the cosmos, and the cosmos holds you close. Good night.
you.